Hey there guys, welcome to my walkthrough of the AQA Higher GCSE Maths November 2017 paper 1. So I'm doing these again because I want to do them better and put them all in one place for you guys. So they are all in a playlist. Every AQA past paper up to now is in a playlist which you can find down below in the description. Also down there will be links to help with your GCSE Maths revision in general, as well as topic playlists to help with questions from this paper. Let's do this. Okay, question 1 wants us to work out the square root of 2 to the power 6 add 6 to the power of 2. So 2 to the power of 6 means 2 times 2 times 2 times 2 times 2 times 2. So that's 64. 6 to the power of 2, 6 squared, 36. So that's root 100, which is 10. Question 2. What is 800 million in standard form? So, standard form is always a single digit between 1 and 9. It can then have a decimal point, but doesn't need to. So, we can rule that one out. And we can rule that one out. So, 800 million is 800 with 6 zeros after it. So it's going to be 8 times 10. Now to work out the power, we count how many places the decimal would move from there to there, which would be 8. So it's 8 times 10 to the 8. Question 3 asks us to circle the expression equivalent to 4 to the power of 5 all squared. So when you have a single term but with different parts inside of a bracket, as we do here, we have 4 and a. The power on the outside affects all of the parts. So we're going to get 4 squared, and then when indices are separated by a bracket, they multiply together. So we're going to get 8 to the power 10. So that gives us 16a to the 10. Okay, question 4. Y is equal to 10 over x. If the value of x doubles, what happens to the value of y? So this is inverse proportion because x is on the bottom of the fraction. So whatever x does, y will do the opposite. So if x doubles, y gets divided by 2. It's halved. 5a wants us to factorise x squared minus 100. So this is a quadratic. It's a special one. It's a difference of 2 squares. So these factorise 2. Well, this one is going to be x plus 10 times x minus 10. 5b wants us to solve 7x add 6 is 1 add 2x. So whenever you're asked to solve, that means get x on its own on one side. So first step, move this 2x by minusing 2x from both sides. So that's going to give us 5x add 6 is greater than 1. Now let's take away the 6. So 5x is greater than minus 5. And then divide by 5. X is greater than minus 1. Cool. Okay, question 6 wants us to work out the value of root 3 squared times root 2 squared. So a square and a square root cancel each other out. So root 3 squared is 3, root 2 squared is 2, so 3 times 2 is 6. Question 7. Here is a quarter circle of radius 6 centimeters. We want to work out the area of the quarter circle, giving our answer in terms of pi. So, a very common mistake here is to go, well, we got a quarter of a circle, so we'll quarter the radius. Don't ever do that, can't do that. What we need to do is remember that the area of a circle is pi r squared. So let's work out the area of the whole circle and then divide that by 4. So the radius is 6, so we would get A is 36 pi centimeter squared. So the area of the quarter circle is 36 pi divided by 4, which is 9 pi centimeters squared. Okay, question 8. 3 whole numbers are rounded to the nearest 10. The sum of the rounded numbers is 70. We want to work out the maximum possible sum for the original 3 numbers. So, let's think up what our rounded numbers could be. So we literally need 3 multiples of 10 that add together to give us 70. So I'm just going to go 30, 30 and 10. So it didn't say that they had to be different. Now we want the maximum value for the 3 original numbers, so before they were rounded. So the biggest number that would round down to 30 would be 34. So we're going to have that twice. And then the biggest number that would round down to 10 would be 14. So the sum is 34 add 34 add 14. And that's going to give us 68, 78, 82. Cool. Question 9 wants us to circle the expression for the range of n consecutive integers. So range is biggest to smallest. Consecutive means one after the other. So for example, 1, 2 and 3 are 3 consecutive numbers. Now the range of those, 1, 2, 3, would be 3 take 1, which is 2. So for 3 consecutive numbers, the range is 2. For n consecutive numbers, the range then would be n minus 1. So That's all going. Okay, question 10. 3 identical isosceles triangles are joined together to form this trapezium. Each triangle has a base of b centimeters and perpendicular height h centimeters. Part A wants us to work out an expression for the area of the trapezium in terms of b and h, giving our answer in its simplest form. So, this is one that we need to know, the area of a trapezium. So, if you haven't yet, check out my formula video down below, where you can also get a PDF copy of my formula sheet that you can print off and stuff. So, trapeziums have a top length called A, bottom length called B, and a height h. Now the area is height times A plus B all over 2. So, this trapezium up here has a top length of B, a bottom length of 2B, and a height h. So the area of this guy is going to be h times b add 2b, so 3b, all over 2. Now that we can then say is 3bh over 2. Cool. Okay, then for part B, we have the same trapezium. Now we know the slant height of the triangle is s, and we are told b to s is 2 to 3, and we want to work out an expression in terms of b for the perimeter of the trapezium. So, perimeter is distance around the outside, so we got B there and another B there, and we've also got another S over there. So up to here we know that P perimeter is 3B add 2S. Now what we need to do is find out what S is in terms of B. So, B to S is 2 to 3. So from that, we can say that B is 2/3 of S. Imagine that B was 2 and S was 3. 2 is 2/3 of 3. So we know that B is 2/3 S. From that though, we actually want to know what S is. So we could say that S is 3/2 of B. So now we're going to substitute that into this. So we get 3B add 2 lots of 3B over 2. Now the 2's cancel out, so we get 3B add 3B, which gives us 6B. Cool. Okay, question 11. So we got a 4 marker here. So 4 candidates in an election were A, B, C and D. The pie chart shows the proportion of votes each candidate received. Now our mission is to work out the probability that a person chosen at random voted for candidate C. So, all of the angles in here are algebraic. What we need to know is the angle for C. So, what do we know? We know angles around a point add up to 360. So we're going to use that. Now we know that a right angle is 90 degrees. So we know the other three have to add up to 270. So we can say then that x add 2x add 10 add 2x is equal to 270. So we've got 5x add 10 is equal to 270. We now want to solve that for x, so take away the 10, 5x is 260. Now we need to divide by 5. So for this, bus stop can help. So 5's into 2, nope, carry the 2. 5's into 26, go 5 times, 1 remainder. 5's into 10, go twice. So x is 52. Now that we know the size of x, we can work out the size of this angle. So 2 times 52 add 10 is 114 degrees. So if we want the probability someone voted C, we want the proportion of C's votes. So that is, let's call it the probability of C, that's equal to 114 out of the total degrees around the point, so 360. Now it doesn't ask for that in a simplified form, so that would do, but let's see what we can do. So there's a common factor of 2, so 57 over 180. Then there's a common factor of 3, so this is 19 sixtieths. Cool. Okay, question 12, we want to use approximation to one significant figure to estimate the value of this bad boy. So, to one significant figure, 0.526 is 0.5. Then we got times. So 39.6 to one sig fig is 40. So we got times 40 squared. And then 97.65 to one sig fig is 100. So the square root of 100 is 10. Okay, so 40 squared, well, 40 times 4 is 160. 160 and times 10 is 1,600. So we got 0.5 times 1,600 over 10. Swap on the top. We got a half of 1,600, which is 800 over 10 gives us 80. Cool. Okay, question 13, nice bit of ratio. So x to y is 7 to 4. X and y is 88. we want to work out the value of x minus y. Okay, so x to y being 7 to 4 is the simplified ratio of x to y. So we know that x to y is 7 to 4. If we did 7 add 4, we would get 11. Now we need 11, or we need the sum of x and y to be 88. Now 88 divided by 11 is 8. So that means the sum of x and y has to be 8 times greater than 11. So that means x needs to be 8 times more than 7, and y needs to be 8 times more than 4. So x is 8 times 7, which is 56. Y is 8 times 4, which is 32. So now we can work out x minus y is 56 minus 32, which gives us 24. Okay, question 14. Two congruent polygons are joined together. So we got this angle here of 60 degrees between them. We want to work out the number of sides of each polygon. So this is going to come down to external angles. So what an external angle is, if this is part of a polygon, imagine a straight line continued there. The external angle is that guy there. Now the sum of external angles or exterior angles is always 360 degrees. So we can get an external angle from this just by halving 60. So then we do 360 divided by 30, which gives us 12 sides. Okay, question 15, we have combinations. So we got a meal deal. Choose one sandwich, one drink, and one snack. There are 7 different sandwiches, 5 different drinks, and 3 different snacks. Part A wants us to work out how many different meal deal combinations there are. So, when you're doing combinations like this, you just multiply the numbers together. So, 7 times 5 times 3. 7 times 5 is 35. 3 times 30 is 90. 3 times 5 is 15. So we got 105. Okay, then for part B we are told 2 of the sandwiches have cheese in them. 3 of the drinks are fizzy. Either picks a meal deal at random. We want to work out the probability that the sandwich has cheese in it and the drink is fizzy, giving our answer as a fraction. Okay, so what we want to do is work out the total number of combinations where she could pick a sandwich with cheese in it, a fizzy drink, and then a snack. So this time we're going to do 2 times 3. So 2 is the number of So how much is we're choosing them? 3 is the number of fizzy drinks times the 3 for snacks. And then that's going to be over the total number of combinations. So 105. So 2 times 3 times 3 is 18. So we got 18 over 105. Cool. Okay, question 16. Water is being poured into a tank. The graph shows how much water is in the tank. So we got the number of litres up the side and time along the bottom. The question asks how much water is poured into the tank each minute. So if we look at the line, then we can see that after 4 minutes there are 60 litres in the tank. So to work out how much is being poured in each minute, we do 60 divided by 4, which gives us 15 litres. Okay, question 17. A and B are similar solids. A has length L centimetres, B has length 2L centimetres. Alex says that the volume of B must be double the volume of A because the length of B is double the length of A. Is Alex correct? Take a box and give a reason for your answer. So, Alex is not correct. When you have similar solids, so let's say we got A and B, which we do. Now we know the length ratio. Now we could just say it's 1 to 2, because we got L and 2L. There's a common factor of L, so we can just say it's 1 to 2. Now, from the length ratio, you can find surface area ratio by squaring both parts of the length ratio. So the surface area would be in the ratio 1 to 4, and you can find volume ratio by cubing the length ratio. So we'd have 1 to 8. So the volume of B is actually 8 times the volume of A. So volume of B is 8 times volume of A. Okay, number 18 wants us to circle the 2 roots of this guy. So roots are solutions, which are what we get from factorising. So when you've factorised quadratic, you set each bracket equal to 0 and solve for x. So if 2x add 3 is equal to 0, 2x is equal to minus 3, so x is minus 3 over 2, so that's 1. And if 5x minus 2 is equal to 0, 5x is 2, x is 2 over 5. Cool. Okay, question 19. The diagram shows a triangle and a trapezium. We want to prove that angle A here is equal to angle B here. Okay, so I know this type of question causes problems. So the trick to it is just thinking about what we know and what we can do with what we know. So, for example, we know angles around a point add up to 360. So we can say that A add C add 65 add 115. So 65 add 115 is 180. We know that that is equal to 360. Now we can take away 180. So we get A add C is equal to 180. Cool. Now, what do we know about B? Well, B and C are inside parallel lines. So, what we can say is because they are between parallel lines, angle B and C are co-interior. So, B and C are co-interior, which means then that B add C is equal to 180. Now what we have here is two simultaneous equations. We know that B add C is 180. We know that A add C is equal to 180. So we can get rid of the C's. So if we call the top equation 1, well, equation 2, let's do equation 1 minus equation 2. So we're going to get B minus A, C minus C is 0, and on the right, 180 minus 180 is 0. So we can add A to both sides and get B is equal to A. Cool. Okay, next up, in 1 month, the number of hours of exercise taken by 10 people are, so we got 4, 7, 2, 8, 6, 5, 1, 8, 2, 3, and 9. We are asked which is the appropriate average to use with this situation. So we've either got the mean, the median, or the mode. So there is this extreme outlier here of 82. So if we were to take the mean, that's going to be heavily affected by this extreme outlier. So the best average to use would be the median. Then we're asked to give a reason for each of the other two as to why they are not appropriate for this situation. So, the mean, as we just said, the mean will be skewed by the outlier of 82, and then the other one was the mode. So remember, mode is the most common. If you look the data, no number came up more than once. So the mode is inappropriate because no value appeared more than once. Cool. Okay, 21. A, B and C are points on the axes as shown. So they make a triangle. The area of triangle ABC is 28 square units. We want to work out possible coordinates for A, B and C. Okay, so it's only 2 marks. I know this question causes a lot of problems, so let's make a sketch of triangle ABC, but let's set him on his base. So this would be A, this would be B, and this would be C. So we know that the area is 28 square units. Now, area of a triangle is base times height over 2. So here we know base times height over 2 is 28. If we multiply by 2, then we get base times height is 56. So then all we need to do is pick values for the length of our base and our height so that they multiply together to 56. So for example, B could equal 8, H could equal 7. So what that would mean is that C would have to be at 7, 0, and then if our base was 8 long, let's have 4 above the x-axis and 4 below. So A could have coordinates 0, 4, and B could have 0, minus 4. Cool. So that is our triangle. Okay, next up, we got some information about the miles per gallon of 60 cars. So it's in a grouped frequency table. Our job is to draw a cumulative frequency graph. So to do that, we need to fill in this blank table. So we still have miles miles per gallon in there. Now, cumulative means to add up as we go. So, in terms of the intervals, in this first one, we're going to have 40 is less than x is less than or equal to 50. In the next one, we have 40 is less than x is less than or equal to 60. So when you're doing cumulative frequency, you keep the lower bound the same. So then we're going to have 40 to 70 and 40 to 80. Okay, so on the right, we now add up the frequencies. So we got 6 in the first one. So this is our cumulative frequencies. And then we add 16, so we get 22. And then we add 28, which gives us 50. And then we get add 10, which is going to give us 60. Okay, so now we need to plot these points. So you use the upper bound of each interval as the x-coordinate and the cumulative frequency as the y-coordinate. So the first point that we want to plot is 56. So there's 50. Our scale upwards is that each little square is worth 2. So we are going to be there. Okay, the next one is 60, 22. So that's going to be there. Next one is 70, 50. So that's going to be here. And then the last one is 80, 60. So that's going to be here. Okay, so what we do is we join these up with a freehand curve. Now where does our curve start? It starts with the lower limit of the info. So it starts at 40. So this probably isn't going to go very well because I can't draw, but we'll have a go. Now what you always get is this stretched out S. Cool. So you should get something that looks like that. Okay, then part B wants us to use the graph to work out the interquartile range. So, they need 2 marks. Again, this paper is so weird, they don't give us a lot of marks for doing anything. So the interquartile range is the upper quartile minus the lower quartile. Now the quartiles are the 25th percent value and the 75th percent value. So, given that our data had 60 in total, our lower quartile is going to be 60 divided by 4 is 15. So we go across from 15 until we hit our graph, use a ruler in the real thing, and then we go down until we hit the x-axis. So I'm going to say our lower quartile was 55. Now for our upper quartile, we go across from 3/4 of 60, which is 45. So we're going across from here and then again we go down. So okay, so I make my upper quartile to be 68. So our interquartile range is 68 minus 55 is 13. You might get it slightly different because our graphs will be different. Anything in that sort of region though is fine. Okay, 23 says the equation of a curve is y equals x add 3 squared add 5. Circle the coordinates of the turning point. So this is completed square form. The coordinates of the turning point are, well, the x coordinate is the negative of the number in the bracket with the x, so minus 3, and the y coordinate is the number on the outside, so we got minus 3, 5, which is there. So what that's going to look like, roughly, quadratic, minus 3, 5. So we are above the x-axis and to the left of the y-axis. Cool. Okay, question 24. We have a cyclic quadrilateral. All that means is a quadrilateral inside of a circle with all 4 corners on the circumference. So we got algebraic angles. We're told that x to y is 5 to 7, and we want to work out the size of angle W. Right, so what we need to know here is that opposite angles in a cyclic quadrilateral add up to 180 degrees. So we can say that x and y is equal to 180 and we can also say that w add x add 20 is equal to 180. Okay, so now that we got those, we don't need the diagram at all. So we know that x and y are in the ratio 5 to 7. We know that x and y is 180. So we need to split 180 in the ratio 5 to 7. So 5 add 7 is 12. 180 divided by 12 is 15. So we multiply each part of the ratio by 15. So 5 times 15 is 75. So we got 5 times 15 to 7 times 15. So we got 75 to 105. Now that tells us then x is 75. Y is 105. But we don't really care about that. So now that we know what x is, we can find W. So now we know that W, add 75, add 20 is 180. So W add 95 is 180. Take the 95 away, W is 85 degrees. Cool. Okay, 25, we got some proportion. So 15 machines work at the same rate. Together, the 15 machines can complete an order in 8 hours. 3 of the machines broke down after working for 6 hours. The other machines carry on working until the order is complete. In total, how many hours does each of the other machines work? Okay, so let's think about this. The 15 machines together take 8 hours to complete an order. So from that we can work out the total number of hours it takes to complete the order. So how many hours of work it takes to complete the order. So the total hours to complete the order, well, we got 15 machines working for 8 hours each. So that's going to be 8 times 15, which is 120 hours. So even though the machines are only working for 8 hours, we add their times together because they are each contributing 8 hours. So, and then 3 of the machines break down after working for 6 hours. So, after 6 hours, we can work out how many hours of work has been completed. So that's been 15 machines working for 6 hours. So 15 times 6 is 90 hours of work done. So there's 30 hours left to do. Because we've done 90 hours of it, but there's 120 hours in total. So there are now going to be 12 machines left working when the 3 break down. So to work out how much longer the 12 machines have to work for, so the 12 remaining machines have to work, well, they are splitting this 30 remaining hours between 12 of them. So they have to work 30 divided by 12 hours more to complete the order. So 30 divided by 12 is 15 over 6, which is 5 over 2, which is 2.5 more hours. So the total time work by the machines that didn't break is, well, we know they worked 6 hours before the other ones couldn't be asked, and now they've done another 2.5 hours, so each one has worked 8.5 hours. Cool. Okay, 26 we have recurring decimals to fractions, so I'll put my stuff down below. So we are told that 0.7 recurring is 7/9. We want to use this fact to show that 0.07 recurring is 7/90. So 0.07 recurring is 0.7 recurring divided by 10. Now that means it's 7/9 divided by 10. Which means, if you're dividing by 10, that's the same as multiplying by 1/10. And then when you multiply fractions, you do the top times the top over the bottom times the bottom. So 9 times 10 is 90. Cool. Then part B says, using part A or otherwise, convert 0.27 recurring into a fraction. Okay, so give your answer in its simplest form, 3 marks. So I'm not going to use part A, I'm going to do this as a normal question. So start off by saying that x is equal to 0.27 recurring. Now what we need first of all is a number with a purely recurring decimal part. So at the moment it's not purely recurring because we got that 2 which isn't recurring. So what we're going to do is multiply both sides by 10. So we get 10x is 2.7 recurring. Right, what we need now is another number with exactly the same recurring decimal part. So what we need to do is just move the decimal point one place to the right. So we're going to multiply again by 10. So we're going to get 100x is equal to 27.7 recurring. Now we can lop off the recurring part using subtraction. So 100x minus 10x is 90x. 27.7 recurring minus 2.7 recurring is 25. We then need to get x on its own. So divide by 90 and we get 25 over 90, which can simplify as a common factor of 5. So we're going to get 5 over 18. So remember the bus stop could help us with that. 90 divided by 5. 5 into 9 goes once. Remainder 4. 5 into 40 goes 8 times. Cool. So our answer is 5/18. Okay, 27 we have probability. and it's 4 marks. So, there are 11 pens in a box, 8 are black and 3 are red. 2 pens are taken out without replacement. We want to calculate the probability that they are both the same colour. So, they've given us this massive space that will be for a tree diagram. So, let's do a tree diagram. So, on the first selection, if we have red and black, we know that there are 8 black and 3 red. So the probability of getting a red is 3/11, and getting a black is 8/11. Now, because we're not putting the pens back in the box, the probabilities are going to change depending on what happened with the first pen. So, our probabilities are now going to be out of 10 because we've taken a pen out of the box. So, if we took a red, there is now 2 red pens left out of 10 pens in total. And that would mean the probability of getting a black would be 8/10. If we took a black, then the probability of getting a red would be 3/11. No, it wouldn't. 3/10. And the probability of getting a black would be 7/10. So there's our tree diagram. We want the probability that the 2 pens are the same colour. So we got 2 paths that we're interested in: red, and then red, or black, and then black. So, when you're going along branches of a tree, you multiply the probabilities together. So the probability, let's say, of red is 3/11 times 2/10. Now that is going to give us 6/110. You might wonder here why I'm not simplifying these fractions. I'm going to wait and see what happens with the probability for black. So the probability of black is 8/11 times 7/10. So that's going to give us 56/110. So those are the 2 outcomes that we are interested in. What we do now to finish off is add the probabilities together. So we get probability, let's call it same colour, is 6/110, and 56/110, which is 62/110. Now that would be fine because they haven't asked for it in its simplified form, but it does go down to 31/55. 5. Cool. 28, we got circles and tangents, sort of. So I'll put my stuff on that down below. So A, B and C are points on the circle. X squared and y squared is 36. A is on the y-axis, B is on the x-axis, M is the midpoint of AB, and COM is a straight line. So, part A wants us to show that the coordinates of A are 0, 6. So, A is on the y-axis. So, on the y-axis, x is equal to 0. Now we know that A lies on the circle, so we substitute x equals 0 into x squared and y squared is 36. So when x is 0, we get 0 squared and y squared is 36. So if we square root, or y is plus or minus 6. So at A, which is above the x-axis, we've got 0, positive 6. The minus 6 is telling us the y-coordinate there, so that would be minus 6. So at A, we have 0, 6 as our coordinates. Okay, part B wants us to work out the coordinates of B. So very similarly, on the x-axis, y is equal to 0. So at B, x squared add 0 squared, so 0 is 36. So x is positive or negative 6. At B though, we can see B is on the positive x-axis, so it's going to be 6, 0. Cool. Part C wants us to show that the equation of the straight line passing through C, O and M is y equals x. Okay, so we know that it passes through the point O, which has coordinates 0, 0. What we can also do is work out the coordinates of M. M is the midpoint of AB. So we now know that B is 6, 0. Now midpoint coordinates are the mean of the two coordinate points at the ends of the line. So for the x coordinate, we get 0, add 6, divided by 2, it's going to give us 3. And for the y coordinate, we get 6, add 0, divided by 2 is 3 again. So we could say that COM passes through 0, 0 and 3, 3. Both of those coordinates have the same coordinates, x and y are the same. So y is equal to x. Because the coordinates are the same. Cool. Okay, then part D wants us to work out the coordinates of C. Giving your answer in third form, and it's 3 marks. Okay, so this is now simultaneous equations. We're trying to find where this straight line hits this circle. So there. So I'm going to do it here, I think. So we know that x squared add y squared is 36. We also know that y is equal to x. So what we're going to do is substitute y equals x into the circle equation. So what we're going to get is x squared add x squared, because y is x, is equal to 36. So 2x squared is equal to 36. Divide by 2, x squared is equal to 18. Square root, and we get x. Now, let's think about where we are. We are in negative x territory and negative y territory too. So x is going to be minus root 18, which is minus root 9 root 2. Root 9 is 3, so this is minus 3 root 2. Now we know at this point y is equal to x. So the coordinates are minus 3 root 2 minus 3 root 2. Cool. Okay, in question 29 we got a sketch of y equals sine of x for x between minus 360 and positive 360. Part A wants us to find the coordinates of point P, and B wants us to find the coordinates of Q. So, P is this point here. So, sine of x is equal to 0 at 0, 180, and 360. And that carries on into the negatives too. So, P then has coordinates 180, 0. Now what we also need to remember is that sine and cos oscillate between 1 and minus 1. So for Q, the y coordinate is going to be 1. Now the x coordinate is exactly halfway between minus 180 and minus 360. So that is a space of 180. Half of that is 90. So minus 180 minus 90 is minus 270. Cool. Question 30, the grand finale. So we got indices. I'll put my stuff down below. So part A wants us to work out the value of 81 to the minus 1/4. So, first of all, negative powers, or the negative part of a power, put the number and the rest of the power on the bottom of a fraction, like that. So, then a fractional power, when you only have a 1 on top, is rooting the number to whatever the number is. So here we want the 4th root. So we're thinking, what number to the power of 4 gives us 81? So 1 times 1 times 1 times 1 is 1. 2 times 2 times 2 times 2 is 16. 3 times 3 is 9, times 3 is 27, times 3 is 81. So the 4th root of 81 is 3. So we got 1/3. Okay, then part B wants us to write 16 times 8 to the power of 2x as a power of 2 in terms of x. So that means 2 to the power of something with x in it. So 16 is 2 to the power 4. 8 is 2 to the power 3. So we could write 8 to the power 2x as 2 to the power of 3 to the power 2x. So we can write this whole thing. In fact, we can simplify that. 2 to the power 3 to the power of 2x. When indices are separated by a bracket, they multiply together. So this is 2 to the power of 6x. So we can now write 16 times 8 to the power of 2x as 2 to the power 4 times 2 to the power 6x. Now we have two numbers that we're multiplying together where the base is the same. So now we add the indices together. So this is 2 to the power 4 add 6x. And that is our final answer. Okay guys, hope you found this useful. Don't forget, every AQA higher GCSE 9-1 Maths past paper can be found in one place in the playlist linked down below. Good luck in your exams, take care, take it easy.